Hello, everybody. I'm very pleased to co-chair this first session with Professor Ed Murphy from UCSF. I will leave him the floor just after a small introduction. So I'd like first to thank the organizer, and especially Fabiola and Graham and all their teams who have done a tremendous work. You know, we know quite well each other, and then myself, that's a lot of work because we organized this kind of meeting a long time ago in Paris for myself and in San Francisco from himself. So thanks a lot, Graham, and congratulations. I've been also very impressed by the first talk from the patient representative, and I was very moved by these talks. Thanks also for that. The last thing I want to say, it's also very nice to do epidemiology because epidemiology session is always the first one. So at least we begin. And in most of the cases, most of the people are here and are still listening, which is not always the same thing at the end of the meeting, I may say. So I will leave the floor to Ed, who is going to take in charge, the first three talks, and after that, he will switch to me. Thank you very much.
Great. Thanks very much, Antoine, and welcome everybody to this first session. We're excited to really hear an update on the global situation of HTLV in the world. And so without any further delay, let's get going. So the first speaker will be Florencia Ramaro from the Universidad de la República and Institute Pasteur of Montevideo in Uruguay. And her title is Current Status and Future Perspectives of HTLV Infection in Uruguay, a Comprehensive Overview. Florencia, the floor is yours. And just a reminder, 10 minutes per talk for each speaker, and there's a clock here. And please hold your questions. There will be a question session after all of the 7 speeches. Okay, thank you.
Hello, good morning to all. First of all, I want to thank the organizers for the opportunity to present here. We will talk about the situation of HTLV infection in Uruguay. So as introduction, Uruguay is a small country located in Latin America between Argentina and Brazil. We have a population of 3.5 million of inhabitants, and it is an aging population. And 90% of the population considers themselves as to have European ancestry, 4.8% African, and 2.4% indigenous. So what we know about HTLV infection in Uruguay? So HTLV screening has been mandatory for all blood donors in Uruguay since 2000. And using the data provided by these national blood banks, the prevalence of HTLV reactive results in blood donors have been estimated at 0.13 between 2012 and 2014. And they found a higher proportion of reactive results in the north of the country, bordering Argentina and Brazil. What is the big problem about HTLV infection in Uruguay? That is a press note here that say that HTLV is a neglected disease in Uruguay. Why? Because the access to diagnosis is so difficult. In Uruguay, confirmatory testing for HTLV is not mandatory and is very difficult to access to this test. And there are no guidelines for monitoring individuals that are already diagnosed with HTLV. And this situation leaves reactive individuals in a vulnerable situation, and we have not accurate data on the true prevalence of the infection in Uruguay, and it's very difficult to take measures to interrupt transmission pathway in the country. To address those challenges, in 2012, began on the formation of an HTLV working group that was comprised of researchers, infectious disease specialists, hematologists, blood therapists, and the blood bank authorities. The main objectives of that group are to understand the prevalence of HTLV infection in the country and the geographic and socio-demographic variables that influence it, to identify the viral genotypes present in the territory, because there are no sequences of HTLV from Uruguay available now, to establish a molecular assay for the confirmation and typing of HTLV infection, and to determine the proviral load of HTLV1. And also, it is important to establish a reference center for HTLV to provide follow-up care for the patients that are already diagnosed. Also, it is important to train the healthcare professionals to take more expertise in infection, because it's the lack of knowledge about the infection between the healthcares, and also to promote the basic and clinical research in the topic and increase the social awareness. So, related to the first objective, we update the data on the seroprevalence in blood donors of HTLV. So we perform a retrospective cross-sectional study based on the data provided by the National Blood Service that include the data for all blood donors donation centers around the country and during the 2011 and 2021 period. Based on that, we found that the incidence of HTLV new cases by year remains low and stable, but when we compare this the incidence of reactive results with other tested disease in blood donation centers, we found that it's very similar, for example, with HIV results. This study gives a seroprevalence of 0.16%, which means like 100.5 reactive results per year, and most of that people don't have access to confirmatory testing. So we don't know the real prevalence of the infection. We also have some information about HTLV infection that is related to the clinical case that are reported. So we have 3 cases of HAM in the 90s, and after that, 1 more in 2018, and only 1 case of ATIL reported in 2016 that was in a patient of Peruvian origin. But the medical profession believe that there may be underdiagnosis because of the difficulty to access to a confirmatory diagnosis and to the lack of knowledge about the infection. The second objective was to develop a molecular confirmatory test. We want to develop a real-time PCR for confirmatory diagnosis and typing, a quantitative real-time PCR for HTLV PBL determination, and a protocol to perform whole genome sequencing in the positive samples. At this point, I want to highlight the importance of this project that was funded by the PAHO TDR program, led by Mirna Biglioni, that give us the opportunity to join a regional team of experts and participate in a workshop in Buenos Aires, and also the transfer of resources and know-how. We are adapting a multiplex PCR, real-time PCR, that allow the simultaneous detection of the pol and the tags gene of HTLV1 and HTLV2 and albumin as a control. We adapt this test for our facilities using the 7 Pro real-time PCR system, and using this master mix. And as a positive control, we design G blocks for pole and tax genes. Our preliminary results, we can use the test to amplify the target genes, and the G blocks shows a good performance as a positive controls. Recently, we have the possibility to test a clinical sample from a patient with suspected TSP, and that already had HTLV-1/2 positive serology. And after that, we have our first clinical sample positive for HTLV-1, and we were so happy to help with diagnosis in this case. And now, the whole HTLV genome sequencing is in progress using nanopore, and we want to do the PBL determination. As perspectives, we want to enhance the efficiency in both singleplex and multiplex formats and determine the limit of detection. Also, do the adaptation for monitoring the PBL in patients with HTLV infection, the validation of the test with clinical samples, and finally, our objective is to transfer of technology to clinical diagnosis laboratories. Related to the patient follow-up, was established a HTLV National Reference Center at the University Hospital to respond to reactive HTLV donors in blood banks and conduct the confirmatory assays. To give some follow-up of confirmed HTLV cases and the study of the relatives, and to receive the clinical cases with suspected HTLV infection. Also, we are working in the training, and for that, there will be a workshop in Uruguay in November. And then I want to acknowledge all the people that participate in this project.
Great. Thank you. The questions will be later. You can have a seat here. Great. Okay. Thanks for staying on time. Our next talk is by India Clancy from the UK Health Security Agency, United Kingdom, and title will be Completing the Picture, HTLV Testing and Diagnoses in England, 2005 to 2021. Okay, Dr. Clancy.
Thank you. Good morning. My name is India Clancy. I'm a surveillance scientist at the UK Health Security Agency, and this morning I'll be talking to you about HTLV testing and diagnoses in England between 2005 and 2021. So in this session, I will firstly provide some background information on HTLV surveillance in England, then walk you through the aims, methods, our findings, limitations from this research, and then our next steps. The UK Health Security Agency is responsible for the monitoring, analysis, and reporting of data on HTLV in England. HTLV-1 testing was introduced in the UK in 1986, and the surveillance of HTLV was established in 1987. This was followed by the introduction of enhanced HTLV surveillance in 2002, as well as the routine testing of all blood donations, in addition to the launch of Sentinel surveillance of bloodborne virus testing, which aimed to supplement the routine surveillance of hepatitis. In 2005, Sentinel was then expanded to include the reporting of HTLV tests. Currently, 13 labs contribute to this, and they cover 80% of the population. As of 2021, the population estimate of those living with HTLV-1 in England has been revised upwards to approximately 36,000 people, and this is a revision upwards from approximately 22,500 in 2000. So despite developments in the surveillance of HTLV over time, knowledge of the patterns of testing and diagnoses in England does remain limited, And so in our research, we aim to examine the patterns of HTLV antibody testing in England using data from sentinel surveillance, along with HTLV diagnoses in England between 2005 and 2021, which were collected through the enhanced surveillance of new diagnoses of HTLV, in addition to examining the demographic characteristics and clinical characteristics of those who are newly diagnosed. In order to achieve this, data for all individuals tested for HTLV antibodies between January 2005 and December 2021 was extracted from Sentinel surveillance. Sentinel collects information on both reactive and negative HTLV antibody tests from 13 participating labs in England. We used a cohort approach where each person was recorded once in each year that they were tested. A reactive test was recorded over any other results, and where multiple tests in a year were negative, information from the first test was used, and individuals with a reactive test were excluded from appearing in subsequent years. New HTLV diagnoses across the same time period were then extracted from the enhanced surveillance of HTLV database, and contributing to this surveillance system are several data sources, which you can see on the screen here. So deaths among people with HTLV from the Office for National Statistics, antibody-positive HTLV tests from the second-generation surveillance system, new attendances to HTLV care at 4 HTLV specialist clinics in England, new HTLV diagnoses among blood donors from NHS Blood and Transplant, as well as confirmed and typed HTLV-positive patients from the Viral Reference Department at UKHSA. There are a number of reasons as to why using both surveillance systems in this research is valuable. So tests obtained from Sentinel allow us to describe patterns of HTLV testing and look at changes over time. Sentinel also contains both reactive and negative tests, which allows us to calculate the proportion reactive. And the enhanced surveillance of HTLV then allows us to describe patterns of diagnoses, in addition to describing the epidemiological and clinical characteristics of those who are being diagnosed. And we can also use both to identify discrepancies in patients who have been referred and attended a clinic following a reactive test. In total, across 13 labs which are participating in Sentinel surveillance, 126,002 individuals were reported to be tested for HTLV in England between 2005 and 2021. And of these individuals, 1,665 had a reactive test for HTLV, resulting in an overall reactivity rate of approximately 1.3%. Across the same time period, UKHSA has received data on 1,494 new HTLV diagnoses. Over this 16-year time period, the number of individuals tested for HTLV by year has continued to increase over time, rising by 207%, equivalent to an 11% increase on average per year. This increase has largely been driven by testing in secondary care, where the number of individuals tested per year increased by 377% over the 16-year period, from 1,499 to 7,158 individuals. Comparatively, in primary care, this increase was much smaller, at 123%, from 195 individuals to 434. If we now take a closer look at where testing is taking place in secondary care settings, this predominantly occurred in haematology and renal services, accounting for 21% and 14% of all individuals tested, respectively. Alongside 26% of individuals who were tested in settings marked as other, which includes outpatients and oncology, each accounting for 4% of those who are tested. As you can see in this graph, a very small proportion of testing has also taken place in antenatal services, accounting for just 0.2% of all individuals who are tested. Looking at the breakdown of primary settings, we can see that these figures are much lower, but testing in these settings mainly takes place in genitourinary medicine and occupational health services, accounting for 4% and 2% of individuals tested, respectively. If we then take a look at the demographic characteristics of the individuals who were tested and those who had a reactive test, where sex was known, greater than half were male, accounting for 51% compared to 49% who were female. The male population tested was also comparatively older than the female population, with a median age of 50 in males compared to 46 in females. and the median age overall was 45 years. If we compare this to individuals with a reactive test, despite more males being tested, the rate of individuals with a reactive test is higher in females at 124 per 100,000 individuals tested, compared to 93 per 100,000 individuals tested in males. Between 2005 and 2021, the number of individuals with a reactive test for HTLV per year has continued to increase over time, rising by 388%, equivalent to a 16% increase on average per year. If we then look at new diagnoses, between 2005 and 2021, 1,494 new HTLV diagnoses were reported to UKHSA, averaging 93 cases per year, with an observed decline in 2020, which is likely due to the impact on services due to the COVID-19 pandemic. Over this 16-year period, we haven't identified any significant change in new diagnoses that are being reported, with the number of diagnoses just fluctuating on year to year. Of these new diagnoses, where sex was known, a greater proportion were female, accounting for 61%, compared to 39% who were male. The female population was also slightly older, with a median age at diagnosis of 54 in females compared to 52 in males, and an overall median age at diagnosis of 53 years. Through our data collection for the enhanced surveillance of HTLV, we also obtain information on the clinical characteristics of patients, looking at the proportion of new HTLV diagnoses broken down by adult T-cell leukemia or lymphoma status. The proportion with ATLL has remained similar but low across the years. This, however, is contrary to anecdotal reports from clinicians who believe that they do see a greater proportion of patients with a diagnosis of ATLL each year. And as demonstrated in this figure, this ATLL status, the ATLL status of a large proportion of individuals is still unknown in our data set, which may indicate some issues with the reporting of this data to UKHSA. Looking at the proportion of new diagnoses each year who are reported to be asymptomatic, this figure has fluctuated over the 16-year period, with an average of 29% of new diagnoses each year. However, similar to ATLL, the symptom status of a large proportion of these new diagnoses does remain unknown. So to summarize the key findings from this research, the number of individuals being tested for HTLV and reactive tests both continue to increase over time, particularly in secondary care. Comparatively, a smaller proportion of testing is being undertaken in primary care. Despite an increase in testing and recently updated estimates that the population with HTLV1 in England has increased to approximately 36,000 people, no significant change has been identified in new HTLV diagnoses over time. And additionally, only a small proportion of cases which are being diagnosed in specialist clinics. The difference in the number of patients with reactive tests and those who are being newly diagnosed in clinics may indicate potential gaps in referral and engagement with care. And the incompleteness of data on ATLL may also indicate gaps in reporting to UKHSA. There are several limitations to this research, which I'll quickly highlight. Firstly, we only receive HTLV testing data from 13 labs in sentinel surveillance. Participation in this surveillance is voluntary, therefore coverage of testing sites across England is incomplete. This also suggests that the gap in referral and engagement in care could be wider than currently exhibited in this research. And additionally, confirmatory testing across labs is inconsistent. So tests presented today from Sentinel do contain a mixture of some confirmed and unconfirmed positives, and as a result, we are referring to them as reactive. As a result, our next steps will be to undertake further investigations to understand the discrepancies in reactive tests and diagnoses between these surveillance systems, and additionally, further work is needed to facilitate testing, confirmation, and referral to care to reduce HTLV transmission.
Great.
Thank you.
Thank you very much. Great. Okay, the third speaker is Daniel Enriquez Vera from the Division of HTLV1 and ATL Carcinogenesis and Therapeutics, Joint Research Center for Human Retrovirus Infection at Kagoshima University in Japan. And the title is The Origin and Diversity of HTLV1 in South America, not Japan, complete genome and Bayesian approach. Okay, go.
Thank you. Hello, everyone. I'm Daniel Enriquez from Peru, but actually I'm doing my PhD in Japan, in Kagoshima University. So I have nothing to declare. So I will start with a story. When I was a kid, I heard this legend that there was a god, a demigod, who came from the sea, created one of the biggest empires in the north of Peru that you can see here. But what is this related with HTLV1? So if you look at this face, probably you will know that the Denisovans that has been discovered 2 years ago, or 3 years ago, is actually related to South American indigenous population, as well as Asian populations, as well as Aboriginal from Australia. So finally, we have the connection between those indigenous communities that are rich in HTLV1. So just to understand the most relevant events for the HTLV1 introduction to South America, we need to know this timeline. There are all the most important steps. So then we know that there is this Chilean mummy that was actually said that it has been contaminated, and it was not believed that it was transcontinental subtype 20 years ago. But one important thing about this mummy is that it has an ancestry of the Denisovans. And also, this ancestry of this population from this Andean part is really close to the Aboriginals from Australia. So that makes now even more complicated to understand how is the origin in the population of South America. You can see here, that means that the front door for the entrance of the human migrations probably was the north of Peru, and then to the south, and then to Brazil, and then to the north again. So, but this is the actual classification for HTLV1, as you can see. It's quite complicated sometimes. And, but there is a peculiar question that I want you to know. The distribution of the transcontinental subtype resembles the Denisovan ancestry, actually. And it's actually respecting that Neanderthal ancestry in Europe as well as North America. So my question is, what is the origin of this transcontinental genotype in South America? So first we have the pre-Columbian theory. There is one main problem with this theory, that in the North America, there is no HTLV1. Not even in Mexico, not even Mayas, Aztecas, or whatever. And then we have a second theory about the slave trading as a late event. But we know that despite Brazil received 5.5 million slaves in the 17th century, there are no African subtypes in Brazil. All of them are transcontinental. And also there are transcontinental subtypes in Asia, and also in Okinawa, in the south of Japan, and in the Polynesian islands. So we are closer to this area than to the other side. And when we check in the ancestry of Peru, it's interesting that we have 92% of indigenous ancestry. Compared to Brazil, there is only 18 and 7% in the south of Brazil. So just to solve this question, or this controversy, so we include a high quality HTLV1 complete genomes, and also we have Peruvian samples, 63 from the Cayetano Heredia cohort. And we actually found one sequence with recombinant signal from Brazil that resembles there is diversity in that country. And then we included 63 high-quality samples. And as you can see here, most of them, 60% had extranguloides co-infection, and then 97% were transcontinental. That is not informative at all. But then we have the maximum likelihood cladogram here. And as you can notice, we have here an aggregate of all the Peruvian samples next to the Brazilian samples that make a new call Andean Amazonian clade. But then we have another Peruvian samples here, just next to the rest of the Asia and other countries. And then there is one sample here that is close to the common ancestor here, directly to the common ancestor, and other samples that are close to the African subtypes as well. And then we can check it out here that there is no Brazilian samples next to the African clade. And then we perform several unsupervised clustering methods, including PCA, discriminant analysis of principal component, and Bayesian hierarchical analysis. And we found that this South American clade is actually distant from the rest of the transcontinental, and even in the same distance that the Japanese subgroup. And there is, as you can see here, most of these samples from South America. There are some South American samples that are in the African subtype as well as in the Asian subtype that were probably from the Nikkei immigration in the last century. And then you can see here how the differences between the Andean Amazon, there's a homogeneous group inside, as well as the Japanese group inside. And there is the same distance probably from the Japanese side to the rest of the clades, and even the Andean Amazon from Africa is far distant, in the pairwise alignment. So again, we can see here the distribution of subtypes, of genotypes of HTLV1, and as there is a more diverse in the coast and even in the capital city, but also we have found a hotspot in the southeast part of the country that belongs to the Amazon Andean clade. Then we perform a Bayesian analysis that has to solve what is the answer for the origin of South America. This is a complex question, and what is important is that after evaluating several methods, we are considering first, we are taking all the priors available from all literature, even the all molecular clocks, flexible or fixed. And then we have these two Peruvian samples as a controls because they were known that are Afro-Peruvian, and they were actually coalescent in the 17th century. And then we have the Australian samples that tend to be the oldest one with 40,000 years before present. So if we consider this calibration, we should know that the cosmopolitan subtype was at least diverging 7,000 years before present, and the origin of the Japanese subtype was 4,000 years before present. That is actually consistent with what has been presented in all Japanese papers. But if we have to explain how was the cosmopolitan subtype expansion in the history, we can see that there are two main events. Here, 4,000 years before present, the cosmopolitan subtype diverged, and there was an expansion here, and then a huge expansion just before even the Incas Empire. So just before even it started at the sea, this area, and then it finishes just before the end of the Incas Empire, there was an expansion of the whole transcontinental as well as the Japanese subtype. So now we can say that the Andean Amazon clade was originated around 2,500 years before present, that actually match with the previous story that I told you from the north coast of Peru. So we are actually proposing an update just to call these subtypes ancient subtypes, and then these as contemporaneous subtypes, and those are the relations of all samples by network analysis. Finally, just to summarize, we have here the Neanderthal archaic ancestry and the Denisovan ancestry in the other side of the country, and that may explain several questions and even more hypotheses about how is the immune response in those patients. So we can start with the out of Africa weight that are made of origin of the Australo-Melanesian subtype of HTLV1, and then when they returned to Africa, they gave origin to the African subtypes that is quite diverse. And finally, there is the contemporaneous subtypes that went through all the Asian areas, including a transmission probably from by the ocean, just to the Andean Amazon region. As a conclusion, I would say that the Andean Amazon is a uniform and well-defined clade, and as the most frequent subtype in South America. And given all priors, it can be argued that HTLV1 was introduced to South America during early human migrations. And we propose an update in the HTLV1 classification based on ancient and also contemporaneous subtypes. And HTLV1 represents an opportunity to study this ancient anthropological migration, as well to estimate the population size. I forgot to mention there is 1 million, according to this analysis, at least, in South America and Japan. Thank you.
Okay, thank you. Good, Antoine.
Hello, so thank you very much. It was a great talk. Now we're going to speak about evidence of HTLV1 in remote area of northern region of Sabah State in Borneo Island, Malaysia. It will be performed by Hidekatsu Iya from the Oita University Faculty of Medicine in Japan. Please.
Thank you, Chairs, Organizing Committee. I'm Hidekatsu Iya from Oita University. Today I will talk about the HTLV1 prevalence in the sub-state Borneo, Malaysia. First, let me acknowledge to my colleagues, especially Professor Kamaldeen Ahmed from University of Malaysia Sabah, who was organizing this research team, and also Isao Hamaguchi, who provided a lot of line blood kits. So when you take a look at the HTLV1 prevalence in Asia, you can find Japan, Taiwan, and Iran are endemic. And you can also find coastal area of China, especially Fujian province next to Taiwan is endemic. Then in oceanic islands and Central Australia, it is the endemic place for HTLV1C. So this is the figure, very inspiring figure from Professor Gesain's review. And we all know HTLV1 is spreading worldwide. But when you look at the non-human primate-derived minus population, most of them are located in Central Africa, except for HTLV1C subtype. So this picture actually made me start my research. So before I start this research, I found one article from University of Malaya Hospital, and they report 2 HTLV positive individuals out of 1,600. Just 2, but 2 are actually HTLV1 positive. So I discussed with Professor Ahmed multiple times, and we set 3 goals. This is here. Then a proposal approved by UMS and state government of Sabah. So the first sample was from blood donor volunteers living in the hub city of Kota Kinabalu, provided by Dr. Sabri. And they are living with more than 40 different tribes. And they are all negative. The next one is from Professor Jeffrey at UMS, and he provided the sample of state government workers, and one sample was suspicious. And third one is from Dr. Kugan, who is working for the primary health care in the northern rural place, Kuda. And we found one suspicious sample, but both of them, we couldn't conduct further confirmation. The fourth one provided from Dr. Kimberly Fornes, who is working on zoonotic transmission of monkey malaria in the whole area of Sabah State. And out of 1,800 specimens, we found 100 more than 100 suspicious samples. Then, with the help of Dr. Hamaguchi, we confirmed 68 positive individuals from here. And it is 3.8% prevalence here. And even considering the total number as a population, 1.8%, and 3 times higher than Japan. And this assay done by Ms. Jung. So this chart presents the comparing Malaysian and Japan incident of cancer and mortal rate. And what I found notable is high ratio of leukemia mortality in Malaysia. So I asked them to start the retrospective survey of HTLV infection among the leukemic patient. And also I asked Dr. Fornes to provide other praise of substate. And back to initial question, we still don't know the origin of HTLV1C. But the cross-species transmission happened in the Sundaland. It connected Malay Peninsula and Borneo in the Ice Age. I think it is logical to see this place as a cradle of HTLV1C. So we start collaborating Dr. Hassan at the Malaysia National University, who is going to provide the indigenous people or orang asli on this research. So that's it. Thank you.
Thank you very much for this very fascinating presentation. We're going to switch now to ATL incidence and HTLV1 serology in the French West Indies over the past decade, and asking Raymond Césaire from the Faculty of Medicine of University of French West Indies to come, please.
Thank you. First of all, I'd like to thank the organizer to allow me to present some data on the ATL incidence and the HTLV1 serology testing in the French Antilles over the past decade. About the prevention of HTLV1 transmission in the French West Indies, Guadeloupe and Martinique are two sister islands, small islands in the Lesser Antilles, and they share similar social economical characteristics and population sizes. And an important point is that they benefit from the French health system and social insurance. We started HTLV1 blood donor screening systematic since 1989, and also antenatal screening was systematically proposed during the first trimester of pregnancy. Positive results contraindicates breastfeeding, and which is replaced by formula. We observed, the neurologist observed a sudden decline of TSP-HAM incidence in the thousands, which was correlated with a decrease in HTLV1 seroprevalence in blood donors. This is the publications 5 years ago from Stefano Lando, neurologist. This is the number of cases of HAM TSPs that were observed each year, and at the beginning of the thousands, we saw a decline of this number of cases. So a question is, what about the incidence of ATL? And we looked also at the prevalence in blood donors and in hospital settings. So HTLV1 is screened by the Établissement Français du Sang in Guadeloupe and Martinique, and the data are aggregated at the national level by Santé Publique France. In the university hospitals of Guadeloupe and Martinique, so they have around 1,500 beds and cover 2/3 of overall births in the islands. All ATL patients are referred to the hematology units, and the virology labs perform screening and confirmation by line immunoassay. So we extracted the anonymized data from the central lab computer systems and cancer registry. So in blood donors, the prevalence during across the study was 0.15%, which is a decrease. In the previous decades, we had a prevalence of 0.45% in the first-time blood donors. So here you see during the 4 years periods, during the last decade, and this is prevalence by age groups, which increase with the age. During the decade, 65 first blood donors were detected, but an important point is that also 19 repeat blood donors were also detected. Now, in hospital settings, HTLV1 serology is routinely prescribed in some units, and we had during the period more than 70,000 tests that were performed. We had 1,279 HTLV1 positive samples confirmed by immunoblot, so giving us a rate of 1.77% during the period in both islands. This is a seropositivity rate in hospital settings by clinical units. And we saw some discrepancy, and what was striking is the high positivity rates in some units like geriatrics, but also pneumology and also internal medicine or multipurpose medicine, up to 4%. This is by prevalence in hospitals settings by age groups. And now in the obstetrical unit, we had a high prevalence, but there is a bias because HTLV1 serology is prescribed only when the woman is hospitalized close to childbirth, only when there is no medical file or if there is no HTLV1 result in the file. So it is a particular population, and this does not reflect the prevalence in the general population. And now about the ATL incidence during the period. We recorded 119 cases of ATL. It is the data from until 2021 because the data from 2022 and 2023 were not consolidated. But we compared during the period, and the incidence rate was 1.07 per 100,000. And there was no significant decrease during the period. Maybe it's too short. And this is the distribution by age groups. And our hope is that until now, we did not diagnose any case born after the implementation of the screening, after 1989. So, a decrease in the incidence of ATL has been recently reported in Kagoshima. And in our study, we did not find any significant decrease, probably by a lack of statistical power. Encouragingly, positive point is that no ATL case was born after the implementation of PMCT-C. And the pyramid of ages also show that it will probably take 1 or 2 more decades to see a significant decline in ATL, as was observed for HAM-TSP. A point is that we observed HTLV seroconversions that were identified in regular repeat blood donors, and this underscores the need to reinforce the prevention of sexual transmission, STI screening, once-a-life testing, counseling, partner or family testing. We have to do much better on this point. In the French West Indies, midwives and pediatricians and obstetricians are particularly aware of PMCT-C. However, we participated to a recent survey in mainland France, and that showed that targeted screening has become neglected. The pediatricians, the midwives, they were aware in the 19th, and as there is no recommendation, it has become more and more forgotten. And this is a point we have to discuss with our policymakers to make new recommendations and to provide better information. The high seropositivity rate that we observed in hospitalized patients is consistent with recent research on the underestimation of the morbidity and mortality associated with this chronic infection. Our study has methodological limitations and do not allow to conclude whether the high rate of positivity that we observed in pneumology or multipurpose medicine units reflects or exceeds the common HTLV1 epidemiology in the general population. So this requires further studies with adapted design. However, the observation of up to 4% of positive tests in pneumology and multipurpose medicine departments urge to reassess the real clinical burden of HTLV1 infection. And this data overall should contribute to the increase of awareness about the need to curb the silent pandemic and also to structure, as it is done in Brazil, for example, to structure integrated and multidisciplinary consultations dedicated to the care of people living with HTLV1. So to summarize, we had the possibility to start with blood donor screening and antenatal screening 35 years ago. We did not observe any case recently born after the implementation of these measures. We have to better organize our prevention of sexual transmission. Also in the 90s, people were more aware about STI transmission, and this is not the case today. And we have also to develop routine care and to organize the follow-up and the information of and to accompany better the people living with HTLV1. If complementing the prevention, we believe our islands are very small islands, but with almost exclusive data, so it provides probably a small model that we strongly believe that the eradication of HAM-TSP and ATL is feasible. And I would like to thank Jean-Claude Vernant, the pioneers, Jean-Claude Vernant, Guy Sobieski, Michel Strobel, Roger Pradino, François Denis, Antoine Gessin, who participated in the 80s to the structuration of prevention. And we can see our neurologist Stéphane Orlando, who worked on HAM-TSP. He's now working in Bordeaux. This is the lab team in Guadeloupe with Benoît Garin, a friend of Antoine Gessin, the lab team in Martinique with Agnès Lézin. She could not attend the meeting. And here the clinical team with Antoine Chéré, who is present. And Antoine is managing the platform, ambulatory medicine platform, and this will be central for the structuration of the care for people living with HTLV1, and also the youngest colleagues. Here, José Luis Barnet, who is a rehabilitation physician, a medical doctor, and it is the next generation that will continue the work in the hospitals of Martinique and Guadeloupe, and with also a goal to better collaborate with our neighboring countries in the Caribbean. Thank you.
Thank you very much.
I think we can now open it up to questions from the floor. Go ahead, and there's microphones, I think. Come on up to the microphones if you can. Or use the Sligo app. I see one or two questions there. We'll get to those in a moment, but we'd really like people to get up too, I think.
Yep.
Question for the last speaker, Samantha. First, a comment. I'd particularly like to congratulate you on acknowledging that antibodies kill viruses by means other than neutralization in an in vitro assay. It's something that is often neglected. However, the evidence for the protective value of antibody in primate infection, including humans, is at best very weak. And you didn't mention the T cell. And immunogenetic evidence from humans and experimental evidence from non-human primates indicates the crucial role of T cells. And to echo a remark made by Fefa Franchini yesterday, even if you are thinking about a vaccine, which I think is a long prospect, then one should consider also, as well as cross-reactive epitopes in ENV, other viral antigens.
Yeah, absolutely.
Yep.
Answering or? Oh, sorry, I wasn't sure. Yes, no, you're definitely correct. And yes, so we're a bit restricted in what we can do with the samples that we have. From the ethics side of things, but also from a sample quality. A lot of these samples from Central Australia are not really very viable, but we've tried to get the most out of the samples that we have. And Ashley Hirons will be presenting more on the immunology side of it at her presentation, I think, on Wednesday. Thank you.
Great. Do you two have questions, right? We do have a couple of questions. Maybe we'll alternate with Sligo just for fun. We want to show that we're using it. There's a couple of questions about the presentation from Sabah province in Malaysia. One was whether the prevalence of 3.8% was enriched for a specific race or population group. And the second question, do you need to begin looking in neighboring countries as well, neighboring regions?
The first question, we are still working on that, so we cannot answer right now.
Yeah. Mm-hmm.
Right
there.
Yeah. So, some of the question is from the
audience.
Yeah. And the second one is the neighboring countries. Yeah, that's correct. And I think the researchers in Indonesia, they also started this research.
Locally.
Yeah, yeah. So, yeah.
Great. Thank you. Graham and Fabiola?
Raymond, thank you so much for your presentation. Very exciting, and I love the data about the published one around the reduced incidence in HTLV as well as HAM-TISP in Martinique, and now data from the other area, which was, sorry, I forgot the island. What was the island called? Guadeloupe, Martinique and Guadeloupe, yeah. So my question was, what strategies do you have in place to prevent the sexual transmission? How are you going to go forward to prevent the sexual transmission of the HTLV?
That is what exactly what you have to. Thank you for your comment, Fabiola. About sexual transmission, I think we need to discuss recommendations, and probably with microbiology and infectious disease society and the policy makers. We have the Haute Autorité de Santé, the health, who provides recommendation, and it's a very difficult topic. But I think that we have to first, when someone gets a result, we do not what we have to do, and as I could saw in St. Mary's, and as it is done in different countries, it's to provide a care, to a possibility to see a specialist. This is the first thing, and to give the information about the routes of transmission and to propose to diagnose family and partners. And this is not done since more than 30 years. We had blood transfusion and PMCT prevention, but now and also we understood due to the recent publication we did all that we had to propose follow-up, a yearly follow-up, and so the integrated and multidisciplinary has to be set up in our countries, in Martinique and Guadeloupe, and French Guiana is also an important part of our West Indies territories, and also in mainland France, because there are more people from Guadeloupe living in Paris or in France than in the island. And there is nothing, in the recent survey, only 1 of 4 labs connected to maternity perform HTLV1. So there is no targeted screening, there are no recommendations. And so this is something we will discuss at the national level.
Thank you.
Good. Yeah, I've got a Sligo if we're going to alternate. The question, for those, there are a couple of you talked about blood donor data, and I guess the question is, in those countries that you reported, does the blood bank perform leukodepletion? And if so, will they be continuing to screen? So I don't know, there were a couple of you that presented that. I don't know who wants, if you want one or two of you to respond to
that. In UK, yeah, please. Yeah.
So in the UK, I personally don't know the answer to that. My colleague who works at NHS Blood and Transport is nodding, so the answer is yes to the person who did ask that. Yeah. Thank you.
About leukodepletion.
Leukodepletion in Uruguay? Yeah, leukodepletion.
When you eliminate leukocytes from the blood.
Yes. The blood donors that give a positive result are eliminated from the...
No. In the actual blood bag, is it then filtered before going into patients?
Yes.
Okay. In all cases, or?
Yes, it's normal.
It's frequent.
Yes.
And Raymond, do you think it's done in France? Leukodepletion, la déleucocytation, in blood donors.
In blood donors, that?
Il y a une déleucocytation, on enlève les...
Yes, systematically the blood components, the cell blood components were
in all France.
Leukodepleted in France since 1998, and in the Guadeloupe, Martinique, and French Guiana since 1992. This is systematic.
Okay. Graham, please.
Thank you. I've got 2 questions. So the first is to Florencia, and it's just I maybe missed it. Can you comment on testing within different medical specialties like hematology and neurology? I mean, there were very few cases of HAM or HTLV diagnosed, but is there testing?
It's not normally testing because there are a few neurologists that have the enough knowledge to suspect about TSP or HAM related to HTLV infection. So some of them, they suspect, they make serology, but with serology they can't confirm the infection. So stop there. They have a patient with suspected TSP or HAM with positive serology, but they don't really know about if it is about HTLV infection.
And the network that you're developing now to deliver that expertise, is there a time frame for that? Or is it in place now?
It's in place now, but in the, I don't know, if someone, neurologist, give us the sample, we test it, but it's not a public policy now.
Okay, thank you.
We hope to be in the future.
You want to comment? I have another question.
Yeah, please.
Okay. Did you want to comment on that?
No.
No.
Go on.
So can I am going to, I think, bring Ed in on my question for Daniel. I was surprised when you said there was no evidence of HTLV1 in North America.
I didn't say that.
No, you didn't say that,
No.
but I thought you might also join the discussion. I was surprised when you said that because my impression has been that there is HTLV1 and HTLV2 in indigenous peoples of North America.
Yeah, if I may say, after that you will answer. I have another question for you regarding exactly the same topic.
So this sounds like we're ganging up on you, but we're not.
Don't worry. So actually, in Mexico, there is no evidence of HTLV1, but there is evidence of HTLV-L2. And in North America, there are more evidence of HTLV2 than, US, HTLV2. And HTLV1 is basically for migrants. But indeed, in Canada, there are samples from Native Americans with HTLV1. So that means that we have a blank space. So probably there are some samples positive in North America. It's not as huge as South America. But there is a blank space between communication through the Bering Strait to South America. That implies that there is no continuous connection, even for the Mayas and the Aztecas and all the Central American cultures that is actually making up then to the Incas and the pre-Columbian cultures. So that's what actually I was trying to say.
Yes.
But in that, if you take that as a reason for something not existing, I've felt for many, many years, why has there not been any HTLV1 diagnosed in Malaysia? And now we have it because it makes sense. So I don't know. Ed, do you have a comment on HTLV1 in North America? Because some of the patterns of high prevalence in North America, they're related to Miami, New York, and Vancouver. But then there are states in the middle of the USA where there's unexpected high prevalence, but they relate to indigenous people to some extent. Maybe not.
I wouldn't say so. I think it's really, but it's.
Yeah.
But I think that really it's mostly imported, maybe with the exception of Eskimos.
Yes.
Yeah,
if I may say,
exception.
there have been some studies in Eskimos in different places, and there are some, even in Greenland. So very probably there have been migration with some HTLV1, and there is also, as some people know here, in British Columbia, for example, there have been quite a lot of studies, if you really dig a little bit. And it's quite interesting to compare the sequence. I have a question for you. I think it would be extremely important to compare your phylogeny by including HTLV1 from Eskimos, from people from British Columbia, and a few others in Canada, and also with all the transcontinental strains in South Africa, in Mozambique, and in Angola, from where most of the population that people Brazil originate. However, there is very few complete sequence. We are doing quite a lot now, and soon they will be available. So you will see, I think it will change a little bit your story, which is fascinating and very well done, by the way.
I would like to reply that this is actually really important. That I would like to ask you to just make a public available complete genome sequences. And we have a lack of African complete genome sequences. We previously have a lack of South American sequences, but it's necessary to complete the whole picture to have available complete sequences of HTLV1. Thank you.
Great.
I have a small question for the Malaysia story. Japanese, please. Yeah, thank you very much. Sorry. Did you try to confirm by PCR or by any other means the serology?
Yes, serology.
Yeah, but even if you know Western blot or Inolia could be very performant, I think it would be very important, to try to confirm that by PCR and also to do large sequencing.
Yeah, we're preparing for that.
Yeah.
But money.
Yeah, no, but no.
Yeah.
Really, if you succeed, which was very difficult to find in a small place in Malaysia, a high spot, I'm quite sure you will do all the necessary story to do the sequence. And the second,
we read your paper, and we prepare that primers. Or the set of primers?
This is really easy to do. Okay.
All right. Okay.
The second thing, 1 second. Did you look for presence, or what do you know about presence of HTLV1 in non-human primates living in this area?
Actually, we corrected monkey blood there, and some of them were positive.
Okay, that will be very interesting to see.
Yeah.
Great. Okay, we're nearing the end of the session, but I see we have a couple of speakers. There are some more questions on Sligo. We'll try to, we may not get to them though, but go ahead.
Hi, I'm Jake from the University of Queensland. I had a question for Samantha. I really enjoyed your talk. Just related to the end, when you were discussing your vaccine candidate, you mentioned that you screened a bunch of different candidates and identified some with prefusion that were able to produce prefusion. And I've had a lot of experience like imaging ENV, and I find it to be an enormously flexible protein. It's really challenging to image. So I was wondering, how did you confirm that they were prefusion?
So that work is ongoing, but we have a few different ways that we are examining that. So we're looking at confirmation in BN page, but we're also looking at retention of binding epitopes for our patient plasma and neutralizing antibody panel, and looking at how these proteins stand up to different physical manipulate conditions as well. So we're still sort of picking our best candidates, but we've just shown the proteins that express the best more than wild type essentially, and that was one of the markers that we were looking for, that our mutations wouldn't reduce expression, because this protein expresses very, very poorly, so anything less than wild type was not going to be usable. We're going forward with the ones that express insufficient quantities that we can actually work with. So.
We should have a chat later. I'd be able to help you get in your expression yield.
Please, thank you.
Thank you.
Okay, one last question.
Hi, I've got a question for Florentina. I noted from your working group formulation back in 2022, there are no patient representative or participants. Are you looking to revise that? And another quick question for India. In your presentation, there is a higher number of females that are affected with HTLV. Is there an understanding of why this prevalence might be the way it is?
pass the micro, please. Thanks.
So about patient representation, we hope to have it, yes, but actually we don't have a lot of confirmed patients, so it's hard to make this now.
So that's a really, really good question. It's something that we were discussing in the HTLV general meeting, which is a meeting that we have with our colleagues in the NHS, and the most recent of which was held last week. I am looking to Graham to provide an answer on that, as I feel like you might be able to answer this better than myself.
I'm looking to Graham.
Sorry to push that onto you.
Yeah.
It's about increasing women.
Well, yeah, I think the general HTLV1 prevalence is known to be higher in women, so I think that's probably the reason. Perhaps the knowledge that and why they're more tested. That is perhaps, since you're using clinical samples, right? You're using from a clinical lab. It's perhaps that the suspicion of neurologic disease or something that is leading that, but it's hard to say with clinical samples. So.
Or is it because women go to the doctors more?
Could be that as well.
Thank you.
Okay, well, I think we're gonna wrap up now. I think there was one question though on the slide I'd like to tell everyone. Graham, do you know whether the slides will be available broadly? I doubt that. From each presentation. Okay.
Okay.
All right.
We got the link.
Yeah. So there will be, remember that we're filming the session so you can look at the films, but perhaps not the slide decks themselves. So thanks, everybody. A great session.
Thank you, Mr. Chairman.
Yeah.